Hello everyone. Today we will see how to calculate your values of a normal distribution function in terms of your GDC. Okay, so this is a question. The age of a graduate students in engineering programs throughout the USA is normally distributed with mean, which is represented by mu. It is 24.5 years, and the standard deviation sigma is 2.5 years. Okay, so our mean is 24.5 and our sigma is 2.5 years. A student is chosen at random. What is the probability that the student is younger than 26-year-old? What proportion of students is older than 23.7 years? And the third question is, what percentage of students is in between 22 and 28 years old? Okay, now there are two ways of doing it, but since we haven't done the calculus yet, so I'll not be covering the calculus aspect of this. I'll not be covering your mathematical aspect of the calculus, but however, I will show you how does a normal distribution curves look like and what the question is actually asking us to do. Okay, so this is our graph, or you can say our normal distribution for this particular question. Okay, now as you can see, this is my curve and it extends indefinitely to both the sides. Okay, and I leave it up to you to check whether this function is almost touching to 0. Points I have already specified to you, so you can check it in the reference to that. Just try to see. Okay, now first observation is this curve uniform? So our mean is, I think, 24.5. So 24.5, I want to check. It should be somewhere between 24 and 25. Yeah, so this point is 24.5 and it is exactly cutting the curve into two equal halves. All right, now next part is our mean is done and standard deviation is given. So the question was asking us to calculate what is the probability that the student is younger than 26 years old. So all the data is in between this curve, right? Under this curve, that means all the area which is shaded under this particular curve till your positive x-axis are our observations in that. So what is the possibility that our student is younger than 26 years old? So younger than 26-year-old means we are interested in students whose age is less than 26, right? So what we want is precisely something called as this. So I want all the values which are less than my 26. It cannot exceed 26. And these are our observations. So roughly around 0.73% is the chance that our students are less than 26-year-old. Now, this, as you know, this is an infinite curve. Okay, this curve keeps on extending and it will never cut your x-axis. So our minimum value which we take, it can either you can take it 0 or you can go as close, as far away as possible. In this case 0 is fine because it is quite away from sigma mu plus or minus 3 sigma range. But usually it is advisable you take minus 1000, minus 10,000. I have taken minus 100. Even I can increase this value. You can take minus 1000. Then also you can see my value is still intact. It is still 0.73. So this is what is about calculation using your GDC. Alright. Now next part of the question says, what proportion of students is older than 23.7 years? So older than 23.7 years. So what I'll do is I'll start with 23.7 years, which is my this part, right? And again going further down the curve. All right. So this was my curve, and starting from 23.7 years, and I'm going this. So 0.63 is the number of students who lie in this range. And again, if you see, I have written my maximum value as 99999. Since the curve is infinite, I can take as far away as possible. Okay, now your next part was what percentage of students is between 22 years and 28 years old. So now we want an in-between range. So now we cannot do what we were doing earlier. So we have to want a specific range. So this is strictly from 22 to 28. So 0.76 are the chances or the observations which lie between 22 and 28. Now this is your graphical explanation of how do we understand our curve, right? This will not be asked to you in exam. These huge equations which I have written on the left hand side, do not worry about this. This is just to draw the curve. Of course I need the equations, but you do not worry. Now the question is, how do we do it with our GTC? All right, so our answers were roughly 0.63 for the first part. So let's see. Now this is my GDC, so I'll go click on calculate. Okay, so we do not need our random norms. This, all right, so ignore this one. What I have written, this was I'm doing something else. So I'll go with menu. Okay, then I'll go to probability, then I'll go to distribution. Now this is a normal distribution. Now this is cumulative. Why? Because we want till 26 years old. So what is your lower bound? It always takes at minus infinity, you can take it. So my upper bound is 26 because I want not more than 26. What is my mu value? It is 24.5 and my sigma value is 2.5. So what do I get? I get roughly around 0.725747, and what the graph was giving us, I think graph was giving us, where is our graph? It was giving us roughly around 0. No, less than, I'm sorry, this was our graph, right? So 0.73 and we are getting here 0.72. Yeah, so graph is not giving us still our three significant figures. So same thing I can do for my part B, almost same procedure. I'll again go for menu, then probability, then distributions, then again normal cumulative distribution function. Now my lower bound will be what? So 23 years old, we want more than that, so 23.7, and my upper bound here is, I think, can I enter plus infinity? No, so I'll take a very huge value. All right, now similarly, now okay, cannot take this one pick. Okay, now my mu value is 24.5 and my sigma value is 2.5. Sorry, my sigma value is 2.5. Okay, so it is again 0.625 and there we were getting around 0.63. Same way we can do for our part C. Here your lower bound becomes 22 and your upper bound becomes 28. So I hope this is clear in terms of your calculation of normal distribution function and the probability of for the given data. And regarding the calculus part, that area under the curve, of course we will be doing in maybe when we start calculus, then you will understand why this area under the curve makes sense in terms of calculation of values. So in case you have any doubt, please let me know. Till then, take care and have a good day.